let's say I give you a scenario like this, right? We shoot an object at an angle of 30 degrees with a speed of 20 meters per second. It'll follow up path like that, right? Let's say I want a few things. Let's say number one, I would like you to find I would like you to find the velocity when t is equal to 2 seconds. Right? I want to find the velocity when at 2, and then let's find the vertical displacement when t is 2. That's right, Joseph? So let's see if we could work that out. So number one, if they give us the speed 20 meters per second at an angle of 30 degrees, can we find the initial horizontal component and the initial vertical component? Yeah. Right? Because remember, we need these things if we have to use the equations, right? So what will be the initial horizontal component? 20 cos 30, and if one is cos, the next is sine. How much is this? Here's 10, right? And 17.3. So we know the initial speeds. So Joseph, you again. Joseph. So I want to find the velocity when t is 2. What are they asking for? Are they asking for the horizontal component, the vertical component, or combination? But combination. Here we go. So let's pretend somewhere here is when t is 2. Right? So they want the velocity here, v. So what do I need to get? In order to find the velocity v when t is 2, what do I need? To get the velocity here, I need the horizontal component and the vertical. And then do what? And then Pythagoras. Okay? So how do I get the horizontal velocity? Let's start with the easier one. How do I get that? Dante, how am I getting that? What did we learn last class about the horizontal velocity? Throughout the journey, stay the same. So we learned that the horizontal velocity is always constant. So when t is 2, the horizontal velocity is still 17.3 meters per second. Everybody okay with that? How are we getting the vertical component now? How are we getting the vertical component of velocity? Adam, what do you think? How are we getting the vertical component of velocity when t is 2? One of these. Which one you will use? First one, because they do our best, right? They do our best, so you can't use these two. So you want to find again, I want to stress the fact that we want to use vertical. Everything here must be vertical. Right? So you want to find the vertical velocity v. We know the initial velocity vertically. We know acceleration vertically, and we know time. So the initial vertical velocity, that's 10. What's the acceleration? Going upwards first, so it will be minus 9.8, right? And time is what? 2. How much is that? Minus what? 9.6. Check it and make sure. Minus 9.6. Anybody get that? Yeah? Everybody can tell me what a minus means? So it means that the particle already passed the middle, going down. That makes sense, Nathan? So the particle is not here, it's somewhere down here. Right? Particle going down. Right? Direction change. It's not going up anymore, going down. All right? So how do we find V? Right? You're set to use Pythagoras, right? Vertical velocity plus the horizontal. So that's the square root of 9.6 squared. You can leave out the minus, it don't matter, right? When you square, it'll cancel out. By 17.3 squared. How much is that? 19.8. 8. Part 2, Emma. Copy down. Think about part 2. How am I getting the vertical displacement when T is 2? How am I getting that? Think about it. Yeah, Emma. What brilliant ideas you have there. Third equation, yeah. So you want to find vertical displacement. So you need initial vertical acceleration. And we have all of that. And we have T and Nathan. T is how much? 2. So S is equal to ut plus a half at squared. Right? So I want to find that distance. Let's call him y. 10 by 2 plus a half by 9 minus 9.8 by 2 squared. That's okay? 0.4 meters. Copy down. Let's change every scenario. Let's go again. So again, I am focusing on using the equations of motion, right? Ready? To our next one. I'm about taking about 10 minutes so as you go. 10 to this is 15 minutes. Hey, so Number 2, the particle is projected horizontally. Underline the word horizontally. A particle is projected horizontally. What, like this? A particle is projecting horizontally from the top of a building, 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 80 meters above ground level. 80 meters above ground level, 80. 80 meters above ground level with a velocity of 30 meters per second. With a velocity of 30 meters per second. Calculate part 1. Calculate part 1. Time taken to reach ground level. Time taken to reach ground level. Part 2. Those would apply the same here. That's fine. Part 2. The horizontal distance traveled. Part 2. The horizontal distance traveled. And part 3. The velocity of the particle just before it hits the ground. The velocity of the particle just before it hits the ground. First thing I want to try from it is catch up what happens. First thing I wanted to do is catch up what happening, right? For the video on the line, I will possible. So I have diagram showing part of it and putting all the info. Let's see. Right, so I've seen some good diagrams right here. It projected like this, right? What's the speed again? 30. And it's traveling. And this distance here is 80. So because it's moving horizontally, what can we say about the initial vertical component? What will that be? If something moving horizontal, what is the vertical component? 0. So the initial vertical component is 0. The rest should be easy. Try part 1 tomorrow. Right. So what's one? Part one? Part one was to get the time taken to reach the ground, right? So it have to be equation one or equation three. Correct? Do we know final velocity? No. Part three. Do we know the vertical displacement? We start here and finish here, so the vertical displacement is 80. We know the initial vertical, that is, and gravity is what? It's going down, right? So it will be positive, 9.8, right? Are you okay with that? And then we're trying to find 4t. What you all get? Tell me what you all use that so we can discuss why wrong instead of just scratching it. What is scratching? But we do know the final velocity. We do know the final vertical velocity. But you all put zero? Yeah, but then here will be zero, here will be zero, and then I have to find it. Right? So you follow why we're using the third one? Because we have vertical displacement 80. We know the initial vertical is 0, and we know A is 9.8 because it's going downwards. Right? Positive 9.8. Right? Try it quick. Let me show you again. What do you get? Right, so part one is SV is equal to UVT plus a half AT squared. We said this is AT. We said this is 0. Acceleration 9.8. And T is what we're trying to find. So T is the square root of 2, right? 160 over 9.8, which is 4.04. Good. To the next part. Next part is what? Horizontal distance travel. So they want, what are they asking for, Adam? What are they asking for? Horizontal distance travel. So they're asking for that distance, right? Let's call that R. Yeah? Try that fast. Huh? Huh? Read that. Franchise here. Part 2 was what again? Part 2 is to find R. So because it's horizontal, we only have one equation we could use. Horizontal velocity by time. Horizontal velocity, we know that's 30, and the time taken is 4.04. How much is that? 121.2. And part 3, they want the velocity just before it hits. So we need to get the horizontal and the vertical. That's okay? So we need those two things. We know that the horizontal velocity will stay 30, but we need to get the vertical velocity. Which equation do you recommend we use to find vertical velocity just before it hits? 1, 2, or 3? Because we know T, we know A, and we know U, right? So we could use this. So the initial velocity, that will be 0, acceleration 9.8, and time is 4.04. So your vertical velocity is how much? 39.6. And then to find your final velocity, you square root everything. 30 squared plus 39.6 squared. That'll give you a velocity. How much is that? So this plus this. Just check about one more time. 30, right? And 39.6.
Yeah.
Same thing? How much?
49.6.
Yeah. Like things just before it happen. So when it hits is when everything will turn 0. So just before it hits is what do you want? Right. So no, you could use this like instantaneous. When it hit, this will be the speed it hit at. So just when it hit, that is time. Ah, oh, to go forward and get the people to come on.
Yeah.
Huh?
So the guy should.
I wish.
Yeah.
I go again now. This one here is a little fast paper. Sorry, I'm pulling up the pure math. Pulling up the applied math. Ignore that one. Right? I do have the next part here. Start here. Was it not? Start here. Was it not? Draw diagram earlier. This one's slightly different. Draw diagram. Right? This one, did he jump horizontally? He jump at an angle. So his part will look like this. That's okay? Yeah, add on a little piece to the top here. Huh? But he didn't do that. He decided not to do that. So he jumped like this. Follow apart, something like that. Well, that's, I guess, that's what he did. So you draw diagram from the right. Right, something like that. Right, the truck is 2.2 meters high.
Yeah.
Speed is 1.6. And the angle is 20 degrees. Right, try that there, come on.
Yeah. Thanks, listen. Pagi lu berapa kenal satu orang sih kita sih harus video.
Wanna get you? New tempo, right? Right. So part one, they want the initial horizontal. Well, yeah. Whenever you're writing initial, use U, right? Then you have it to using those values. So the initial horizontal, that'll be 1.6 cos 20. How much is that? 1.5.
Yeah.
And the initial vertical, how much is that? 0.5 meters per second. Next part two. Right, Nathan? How are you doing in this part here? Part two. Wait, vacation. Yeah. Part two is the yeah. Time taken for the ball to reach the ground, right? So what we gonna use equation 1, 2, or 3? 2. But do we have B? Right? So we have to use the third equation, Nathan. Right? So what is the displacement here earlier? What's the displacement when the ball hits the ground? 2.2?
No.
Minus 2.2. Why? Because it's below the starting point, right? So if you went here and you reach up here, anything until right here, that is zero displacement. Once you go below your starting point, Mikhail, it will be minus. So it will be minus 2.2. Right? The initial velocity vertically 0.5. We don't know what is t. Do I put positive 9.8 or negative? Right? Because it starts going upwards first, right? So that will be minus t squared. Well, most of the questions is 9.8. So you're in the habit of using 9.8. You okay with that? Solve the quadratic for me now. Solve the quadratic. And tell me what you get for t. What's half of this again?
4.8.
Huh?
Minus 4.8.
So that'll be minus 4.9 t squared plus 0.5 t plus 2.2. Tell me what you get for t, right? I'm right now. Just be I'm sure we catch it.
Yeah. The exam is next week, so after you got it, that's like
How much is that? Well, it's what is now. Where's what myself now?
in us. Last something was 6 8. I want to get up to 7. 1 and 7.
I'm up to date.
Who's the name of it?
How much is this? Okay, let's solve the calculator. How much? 0.72. Sure. 0.72. So it's right time to hit the ground. What's the last part? What's the last part? How far from the truck? So they want? What do you want, Joshua? I mean, I'm Joseph. What do you want? How far from the truck? Horizontal or vertical? So they want this horizontal distance. Right? Right, Mikhail? What are you using?
You just got it?
Yeah.
Oh, my mind, they're out there, don't you?
S equal to V by T. That could work. Everything horizontal. So what was the horizontal velocity? 1.5 and T is what? 0.72. Same time. Right? How much is that? 1.08. Let's go again. Huh? No, we have a projector. Right, do I make all do this graph? Well, no, think of it, hang on to this. I want to do in 2019, but it's not going to a graph now. And I know what the answer. Yeah, but I don't have it back. All right, forget 2019, right? Because I'll cash it. But I'm not going to do that. No, it's just about sine versus sine squared on. Yeah, the graph is height versus sine squared. I'm waiting. Multiple choice. Take a little read some more things, multiple choice there. Let me get some help, Adrian. Help me with this one. What would it be? A stone is thrown A to D, the stone follows a parabolic path, such that the highest point is B. C is the point just before it lands at D. The vertical component of acceleration of the stone is what?
Yes.
Push up, sorry. Sorry.
See us. See us. Yeah. See us. Yeah.
What's the answer they're going with?
B.
Which one?
B.
Right, so the vertical component is the same as C and B. Nothing at A, nothing at D, and the cartels. It will be the same thing as B and C. Nice. Last one. Last one. This belongs to 2006. 2006. Sorry. That one had the answer. Sorry.
Yeah.
Yeah, this one, please. Derive an equation and then find H. Derive an equation and then find H there. Come Nathan, hurry up. You're done? Adam, I said hurry up now. Nathan, what you doing, buddy? Last question, find H. Derive the equation and find H. Easy, so you got to finish fast. Right, after this, we do something called terminal velocity. Yeah, we are. Awesome, hurry up. I want to go online when I come to class.
Yeah, that. Saan single to glass.
Right. Hurry up, try that yet. Last part will be done and then we do terminal velocity. Nathan, how many board Nathan? How many board on? Hey, you come on, sit down here, come on.
Yes. Okay.
So we have horizontal velocity is 5. Should be u, right? And not v, right?
Sorry.
What is that u?
What's the
Right. And what's the initial vertical velocity?
0.
0, right? So write that uv is 0. Nice. They give you a horizontal displacement is 10, okay. Derive an equation.
Oh, should I know the question? Okay, right? Then I'll look up.
Right, derive an equation for the ball's trajectory. So they want a relationship between the vertical displacement and the horizontal displacement. Some between y and x.
Boleh bakal. Bakal.
Right, so what are you doing here? He doing what? What are you doing here? You say S is 10, no? That correct? 10 is your 10 is your horizontal displacement. So your chi is 10. Ten is your horizontal displacement. So your chi is 10 there. Yeah? So go ahead. Huh? We could. I'm trying something for next week. Oh, serious? Yeah, but not everybody. I'm telling something. Right, so what's here? We know that the initial vertical velocity is 0. The initial horizontal velocity is 5 meters per second. Right? The vertical displacement is y and the horizontal displacement is x. Everybody okay with that? What do we know? We know how to find, we know that displacement is velocity by time for what? Horizontal, right? So it means that time is equal to s over horizontal, which is 10 over 5. So the time taken for this journey is 2. That's okay? Now, they ask us to find h, right? So if we use s is equal to ut plus a half at squared, we'll get s is equal, sorry, s is h, right? We'll get h is equal to 0 plus a half by 10, right? Using 10 by 2 squared. So that's 20. Sorry. That's 20 there. Are you okay with that? That's all. The equation they are talking about is instead of writing 10, write x. So instead of writing 10, write x. Right? The final answer is 20 meters. Right, that's technically what we did in one of the examples. Okay. Copy it down, and last thing, head up terminal below. What is it? What should I do?
Okay,
Ready? Last thing I'm done. There's a concept called terminal velocity. Adam, last thing, 5 minutes I'm done. Well, no, I have 10 minutes. 15 on the way. Ready? So I want you to understand something called terminal velocity. What do you understand by terminal velocity? Anybody?
so that the maximum speed of an object must be equal to the
Maximum speed.
maximum.
All right, we can work at maximum. Right? So here's what's happened. As an object falls, here's what's happened. As the object falls, of course, it starts with a velocity of 0, right? As it falls, its velocity increases. And there's a particular point in time as it falls that the velocity starts to get constant. That special velocity is what you call a terminal velocity. Right? So how do we explain that graph? Let's say I give you an object. What are the forces acting on this object? Adrian, what are the forces acting on this object right now? Weight?
Yeah.
Gravity is not a force, weight. What is acting? It's not moving. What is acting on it? Upthrust. It also has upthrust. So right now it's in equilibrium, right? So right now, so at equilibrium, weight is equal to upthrust, right? But as it begins to fall downwards with a velocity v, it falls into a uniform gravitational field G, right? What will it have? As it falls, it will have a next force acting on it. What we call it? As the object falling, there's weight, there's upthrust, and one more force acting on it. Air resistance, drag force. So there's a next force called drag force. And drag force is proportional to the velocity it's moving with. Right? They call FD, right? Drag force. So the faster it goes, the larger this will get. Are you okay with that? So as the object falls, what will happen? So as it falls, as the object falls, which is larger? The weight is what? It's falling down, right? So the weight is greater than the upthrust plus drag force. Are you okay with that? But as it falls and it's going faster, so since V increases, the drag force what? Drag force will also increase, right? Emma? That makes sense? Drag force will also increase. What will happen after a while, Daniel? if this getting bigger, what do you think will happen after a while? You reach a maximum, right? And what will happen? What will happen then? So if this getting larger, will this always be greater than this? If this getting larger, if this getting bigger and bigger and bigger, there's a point in time when this will be equal to this. So at time t, here's what happening. Weight is equal to the upthrust plus the drag force. That's okay. Therefore, the resultant force is what? What's the resultant force? Dante, what's the resultant force? 0. Yeah, correct. And if the resultant force is 0, then acceleration is what? 0. Right? Remember Newton's second law? Acceleration is 0. But if the object still falls and acceleration is 0, what do we know? This implies that velocity is constant. Right? This velocity is called terminal velocity. Right? So the velocity is called terminal velocity. Yeah, sure. So you have to be able to explain this, right? The full note in your handout, but you could copy down this shortened version, right? Right, Adam? You could copy down this shortened version, Adam. Right? We will attempt some past papers on this next one.
Yes. Can I get? Yeah, let's take to a much better one and fix it time. Okay.